I'm Anil Kumar sharing with you an application of sine law. At times, we are given dimensions of a triangle and we might not be in a position to draw any triangle, or we might make one or two triangles. So all those cases are considered as ambiguous cases, as we are not very sure that from the given parameters or dimensions how many triangles can be formed, right? So these are the ambiguous cases which we are going to consider in this particular video. It's an application of sine law, as I'm saying, because we will be considering triangles kind of like this, where we are given angle, one angle and two sides, right? So that is what is given to us. Now in my examples, I am taking this angle as angle A and the sides are A and B, right? So these are the examples which I am taking. So basically you'll find that we have a combination where sine law can be applied. So angle A is not the included angle. That is important to understand, correct? If angle A is included angle, then sine law cannot be applied, correct? Okay. So the question for you is to just determine the number of possible triangles for these scenarios. In first few, 4 of them, we have an example where angle A is less than 90 degrees, where angle A is less than 90 degrees, which is an acute angle. And in the other 2 scenarios, we have a case where angle A is greater than 90 degrees, which is obtuse angle, correct? Now, depending on the condition or the dimensions of A and B, we need to decide whether we are in a position to make a triangle or we are in a position to make 2 triangles or no triangles at all. That's the question for you. So you can always pause the video, answer this question, and then look into my suggestions. Now, before getting into the answer for all these questions, I'll take up the basic concept which is going to help us understand how to solve such questions. And then I'll take few examples from these 6. Okay, so the basic concept here is that we could have different scenarios. I have divided them into 3 cases. Case 1 and 2 are for acute angle, where angle A is less than 90 degrees, and case 3 is for obtuse angle, where angle A is greater than 90 degrees, right? Now let's consider obtuse angle first. That is to say, we are considering a triangle where angle A is greater than 90 degrees. So the scenario could be kind of like this. Angle A greater than 90 degrees means somewhere there. So we have a triangle kind of like this, right? So let's say that's the base of our triangle. Now in this particular case, my vertex A is right there and side opposite to A is this side. Clearly, you can see that a triangle can be formed if and only if, this is side B for us, so a triangle can be formed if and only if this side A is greater than B, right? If it is less than B, then the scenario will be kind of like this. So if it is less than B, let's say this is the length B. If A is less than B, then from here you can hardly approach this place, correct? So you will be kind of in between. So in that case, no triangle can be formed. In case it is equal to B, in that case again a triangle cannot be formed since it will just overlap B. Do you see that? So what we see here is that if A is less than or equal to B, no triangle is formed, but A has to be greater than B to form a triangle, correct? So that is your case 3. Now let's look into case 1 where A is an acute angle. We could again have different scenarios. First one, we'll consider when length A is greater than B or equal to B. It is kind of like this. If I have B as this dimension, and if A is equal to B, we make an isosceles triangle, correct? And if A is greater than B, if A is greater than B, in that case we make just one triangle. So that is the case 1, right? This is your case 1. So in case 1, A has to be either equal to B, you make an isosceles triangle, or greater than B. Perfect. Now the other scenarios could be that you are given side B and the angle A. Now A is equal to B sine A. That is to say, A is equal to B sine A, which is this dimension. In that case, you form one triangle, which is a right triangle. Correct? Now, if you have a condition, so this is B sine A. I mean, where this is B, right? You could have a condition where A is greater than B sine A. That is to say, if this is B sine A, and if you have A as greater than B sine A, but A is less than B, A is less than B, in that case, it is possible that you make two triangles. Do you see that? So both are A. This is B, this is triangle A. So you could make two triangles if A is greater than B sine A but less than B, right? Because greater than B was case A. In this, we're considering A less than B. Perfect. So you could make two triangles. And in this case, you'll also notice that the angle at B are also related. So angle at B and B dash are related. We can say angle B, this angle B dash, will be equal to 180 degrees minus angle B, correct? Since this is an isosceles triangle, that angle will also be B, right? So this is 180 degrees minus angle B. So that is your other case. So I think the cases are very clear to you. And now based on this, we'll try to answer our question. So let's look into these conditions once again. What are we given here? We are given a triangle ABC, angle A is 60, that means acute angle, right? So it's just acute angle. A is greater than B. Since A is greater than B, we have only one triangle. Perfect. In the second case, we have A less than B, right? So it is again acute angle where A is less than B. In this case, we could have three scenarios. So to check which one is valid, we'll find the value of B sine A. In this case, B sine A is 30, sine of 50 degrees, correct? So let's use the calculator. So what do we get? We get 30 sine of 50 degrees equals to 22.98. So what we see here is that A is greater than, A is 25, right? So A is greater than B sine A. So if A is greater than B sine A and A is less than B, so how many triangles do we make here? We make two triangles. So that is the case for two triangles. Now the next example here is another acute angle. A is 10, B is 25. So A is less than B. So let's calculate what is B sine A. So in this case, B is 25. So 25 sine of 40 degrees is equal to, let's calculate, 25 sine of 40 degrees is equal to 16.06. Now, which is greater than A, or A is less than B sine A. Since A is less than B sine A, we cannot form any triangle, correct? So, no triangle. Next example, again, A is acute angle. A is less than B, so we should always check for B sine A, which is 30 sine 64.2. So let's try to calculate this. 30 sine 64.2 is equal to 27. So in this case, A is equal to B sine A. Perfect. And therefore, we can make one triangle, and this triangle has to be a right triangle. 90 degrees. The last two cases are when angle is obtuse angle. So here, in both these cases, we have obtuse angle greater than 90 degrees. So we have to only compare the values of A and B to decide how many triangles. So in this case, A is 27, B is 30. Since A is less than B, no triangle. Right? Angle A is 102. So obtuse angle, side A should be greater, right? That makes sense. In the last example here, we have angle A of 110 and side A of 50. So since A is greater than B, we have one triangle, correct? Now we'll actually take up these examples and solve for the triangles. I'll take up two of these examples. One is this one with obtuse angle, and one where we have two triangles, right? So we'll take these two examples now. I hope with this the concept is clear as to figure out when we will have ambiguous cases, that is two different triangles, when we'll have no triangle at all, or under what condition we could have one triangle. Now let us solve for the triangle given in our previous cases. So we will consider the triangle ABC, where angle A is 50 degrees, side A is 25 centimeters and side B has length of 30 centimeters. So let us sketch this first. So we have, let us say, longer side for B, a smaller side for A. Okay. So in this particular triangle, we are saying that angle A is 50 degrees. Side length A, which is opposite to, is 25 degrees. And B, we'll consider always this side, is 30 centimeters and 25 centimeters. This is vertex B and that is vertex C. Now we'll solve for this triangle. That is to say, we'll try to find out what is this angle B to us, right? Now initially, what we do is, let's try to figure out if this side 25 is greater than the perpendicular or altitude of the triangle or not. So we will check for B sine A. That is to say 30 sine of 50 degrees. B sine A in this case is 30 sine of 50 degrees is equal to 22.98. Now as you can see, this side is 22.98. So that means A is greater than B sine A, right? And that clearly indicates that we have two triangles possible. Correct? So one triangle is as shown here. The other one will be like this. where these two sides are of 25 centimeters each. So this angle will also be equal to the angle B. So let's find angle B using sine law. Since we have to find angle B, I'll keep sine B on the top. Over side opposite to B is 30. We know 25 and 50. So that is sine of 50 degrees over 25. So that gives us sine B as equals to 30 times sine of 50 degrees divided by 25. So we have 30 times sine of 50 degrees and we'll divide this by 25. That gives us 0.91925. That is sine B. So the angle B is equal to sine inverse of this angle, which is 0.91925. So we do shift sine inverse of our answer, and this is 66.8. We can always round this to 67 degrees. So I'm rounding angle B to 67 degrees, correct? Now, let's write down here. So in the given triangle, we found that angle B is equal to 67 degrees. Now let's call this as a point D for us. Okay, so in this particular case, angle CDB will also be 67 since it's an isosceles triangle. So we know angle CDB is also equal to 67 degrees. So what is going to be angle ADC? Angle ADC will be 180 degrees minus 67 degrees, right? So we have rounded our figures to whole numbers. 113. So that's an obtuse angle, 113 degrees, right? So basically, for these two different cases, which are kind of like this, let's draw them separately. So one is the case kind of like this. The other one is this. So what we know here is these sides are 25, 30. In this case, the angle is 50 degrees. This angle is 67 degrees, correct? Now, in this particular triangle, we can find other dimensions. Let me write down ABC here. So angle C here will be, so angle C, which is ACB, will be equal to 180 minus 50 minus 67. 180 degrees minus 50 degrees minus 67. Is that okay? So 180 minus 50 minus 67, it gives you 63 degrees. So this angle is 63 degrees. To find the side length AB, we can again apply the sine law. So we can say that AB over sine of 63 degrees is equal to 25 over sine of 50. And therefore, AB is equal to 25 times sine of 63 degrees divided by sine of 50 degrees, correct? So let's find this value, which is 25 times sine 63 divided by sine 50. That gives us 29. So in this case, this length is 29. Perfect. Now let's solve the other triangles. We have to solve both the triangles. It's kind of important to understand that. So here we know A, C, and this is B dash. The side here is 30, 25, and this angle is 50 degrees. We know this angle as 113 degrees. Correct? So we can find the other angle also, which is, or you could find only also from here, since we know this angle is 67, so the interior angle should be 17 degrees. So either way, right? So this is 17 degrees for us. Exterior angle is sum of two interior angles. Do you see that? So we could use that also. Or 180 minus these two. Anyway, A dash AB dash over sine of 17 is equal to 25 over sine of 50 degrees, and therefore AB dash is equal to 25 times sine of 17 degrees divided by sine of 50 degrees. So we get 25 sine 17 divided by sine of 50 degrees is equal to 9.54 centimeters. Correct? So we get that dimension as 9.54 centimeters. So the second triangle has 9.54 centimeters as the length AB, right? So that is how you could actually solve both the triangles in the given scenario. Correct? Now let's take one more example from our list. So I'll take obtuse angle this time. So here we are considering triangle ABC, where obtuse angle A is given to us as 110 degrees, side A is 50 centimeter and B is 30 centimeter, right? So let me sketch this. So let's say something like this. A is, this is B, which is 30. Angle A is this angle, and that's the kind of triangle we have, where this dimension here is 50 centimeters. This is 30 centimeter. Here we have 110 degrees. So A, B, and C. Correct? Now, since we have obtuse angle and side A is greater than B, we have one triangle. We can solve this triangle using sine law. So let's find first the angle B. So we can say sine B over 30 is equal to sine of 110 degrees over 50, or we can say B, angle B is equals to sine inverse of 30 times sine of 110 degrees divided by 50, right? So we can also do it in one step. So we'll do shift sine inverse. So within bracket, we can write 30 sine of 110 degrees, right? And then it's better to use two brackets actually. Some calculators may give us correct result at this stage, but some may not, right? So we have everything here calculated. So one bracket closed for this, and then we say divided by 50, bracket close. So that gives you 34.32. So we get angle as 34.32. We'll just round it to 34 degrees, right? Since we have 110 degrees here, we can round all to whole numbers. So I'm rounding this to 34 degrees. Now from here we can say what angle C is, right? So angle C is equals to 180 degrees minus 110 degrees minus 34 degrees. Correct? So let's do that. So it is 180, take away 110, take away 34. That gives you 36 degrees. So this angle is 36 degrees. Now side AB, to find that out, will again apply sine law. So ambiguous cases which we are working on, they are application of sine law. So side AB over sine of C, which is 36 degrees, is equal to 50 over sine 110 degrees. We're rounding all our answers to whole numbers. At times you may need one or two decimal places for more accurate results, right? So from here we can say AB equals to 50 times sine 36 degrees divided by sine 110 degrees. So we have 50 times sine of 36 degrees and we'll divide that by sine of 110 degrees. That gives us 31.27. So the side AB is 31.27 centimeters. Correct? So we have solved the triangle completely. You could see that angle 34 is smaller than 36 and therefore the side 30 is slightly smaller than side opposite to 36, 31.27. So that shows that the calculations are correct, right? Approximated, of course, to whole numbers. So that is how you could actually solve such questions. I'd like you to do rest of them yourself. Here is the original sheet, right? I hope the method is absolutely clear. Feel free to share your comments and views. If you like and subscribe, it'll be great for me. Thank you and all the best.